Alright, here we have lecture 1.5, which corresponds to section 2.6 from the textbook. So if you're curious, this is mostly from section 2.6. As previously mentioned, I don't follow the book exactly, but you can reference that section of the book for most of these materials. We're going to open up with radical equations. Now, a radical equation is an equation with a variable in the radical. And instead of just telling you how to solve these, I bet your spidey senses are good enough. So we've been solving lots of equations already in the beginning of the class, and you've already figured out that it's a game of using inverse operations. So if we want to cancel addition, we use subtraction. If we want to cancel out division, we use multiplication. And if we want to cancel out a square root, suppose we have this equation, square root of x equals 9, then we can do the opposite of that, which is square both sides. And when we do that, we get x equals 81. Now, a word of warning here, this is not an application of the square root property, which we covered in the last lecture. The square root property involves us implementing the square roots. We're not taking the square root here, we're doing the opposite of that, we're squaring. So we do not need a plus or minus symbol here. The solution is 81, and you can clearly see negative 81 would not be a solution. If you try to input negative 81 into the original statement, you would get 9i. 9i is not equivalent to 9. So always make sure that your solutions make the original statement a true statement. So it's the same strategy before in that we're using inverse operations. So the inverse of a square root is squaring. So the strategy is to isolate that square root, square both sides. Now if it's a cube root, you'll cube both sides. Once you take care of the root, go ahead and solve. It is very important that you isolate first. That must be done first. So if I look at example number 1 here, I don't want to immediately square both sides. What I need to do is subtract 4 from both sides. And you get equals negative 1. Now, if you're clever, you can actually stop here and realize that there is no solution because a square root can never produce a negative number. It doesn't matter what x is. Square root of a positive number is positive. Square root of 0 is 0. Square root of a negative is imaginary. No square root of any real number is ever going to produce a negative value. So if you catch that, you can actually stop yourself and realize, oh, hey, this is actually going to be no solution. This can never be a true statement because no square root is ever going to produce a negative value. But suppose you didn't catch that. If you didn't catch that, then you can go ahead and square both sides. You get 3x minus 5 equals 1. Then you get 3x equals 6. X equals 2, supposedly. Now, if you go to check this, you'll see that it doesn't work. So if we input that into the original statement, so set x equal to 2, and let's see if that's true or false. I'll put a little question mark over the equation so we don't know if that's true. That's going to be 6 minus 5 is 1. Does the square root of 4 plus this, does 4 plus the square root of 1 equal 3? No. This is false, which means that solution is extraneous. So even if you finish solving it, you arrive at an extraneous solution. The conclusion remains the same, no solution. So just a heads up, when you're solving a radical equation, you do have to check your answers. You do have to check your answers. Alright, so let's go ahead and look at this. Before we square both sides, we need to isolate. So that's 4 minus the square root of 4 minus x equals x minus 2. We're going to go ahead and square the left-hand expression, square the right-hand expression. So when we square the left, we get 4 minus x. When we square the right, we have to be very careful here. What we're doing here is we just square both sides. So we are squaring the entire expression, not just the terms. So when I say x minus 2 quantity squared, that means x minus 2 times x minus 2. So you have to FOIL here. So when you FOIL, you're going to get x squared minus 4x plus 4. And now we'll go ahead and notice that it's a quadratic, so we're going to go ahead and set to 0 since it's a quadratic. So we'll subtract 4 from both sides, add x to both sides, and we get 0 equals x squared minus 3x. So we can go ahead and factor that. So we'll go ahead and factor that. That will factor to x times the quantity x minus 3. So x equals 0 or positive 3. Now we want to go ahead and check both of these. If we check the 0, you'll note when we plug it in, we get 2 plus 2 equals 0, which is false. So 0 is extraneous. Let's check. If you plug in 3, you get 1 plus 2 equals 3. 3 works. So the solution is actually 3. So sometimes you'll get multiple solutions where one is extraneous and the other one works. You do need to check them both. So let's go ahead and look at another example here. So the good news here is the square root's already isolated, so we can go ahead and square both sides. So squaring cancels the square root on the left. On the right we got 2x quantity squared, so that's 2x times 2x, which is 4x squared. Note the squared is a quadratic, so we want to go ahead and set to 0. So when we set it to 0, we get 4x squared minus 11x minus 3 equals 0. Now, if we look at this, you can try factoring. The factoring looks like it's going to be a little bit difficult, so we'll go ahead and run our quadratic formula. So x equals, let's see here, negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. So when we simplify that, let me grab my calculator real quick. So that's going to simplify down to, 1 second here, 13. So that simplifies to 11 plus or minus 13 divided by 8, which simplifies down to 2 numerical solutions. So we got 11 plus 13 divided by 8 is 3. We get 3 for one solution. And 11 minus 13 divided by 8 is negative 1/4. And what we need to do is check both of these. So if you plug 3 in, 3 will work. Negative 1/4 is extraneous. So again, 3 is the solution here. Alright, so that's enough with radical equations. Let's look at equations of quadratic type. So an equation of quadratic type is an equation that is quadratic in structure, but isn't exactly quadratic. So what we can do with a lot of times with an equation that's quadratic in structure, even if it isn't quadratic, we can kind of treat it like a quadratic. So we can do some clever factoring or some substitution. So, for example, if we look at this example number 1, it's not a quadratic. Notice, it's a degree 4 polynomial. Quadratics are degree 2. You can see here the highest power is 4. So it's definitely not a quadratic, but it's kind of structured like one. So let's see if we can kind of factor it like a quadratic. So it will factor if we use 5 and 3, where we have plus 5 and minus 3. But we won't have x's up front, we'll have a x squared. And I highly recommend you can go off to the side and check your factoring. So let's go ahead and check our factoring. So if our factoring is correct, then when we multiply these, we should get back to the original expression. So if I multiply those, I get x to the 4th minus 3x squared plus 5x squared minus 15, which is x to the 4th plus 2x squared minus 15. So check, it works, so our factoring is good. So it's set to 0 and we have it factored, so we can use that zero product property. So either x squared plus 5 equals 0, or x squared minus 3 equals 0. So here we have two little quadratic equations. Here we get plus or minus I root 5. Over here we get x equals plus or minus square root of 3. So here we actually get 4 solutions. And I get those from applying the square root property. So remember, when you use the square root property, don't forget the plus or minus. So we get 4 solutions, 2 of them real, 2 of them complex. Now let's look at an example that is technically quadratic. So example number 2 is a quadratic equation, but it's a little more, well, has some busy work if you want to multiply all that out. But instead of doing the busy work, we can do some clever substitution. Notice both the first term and the second term contain an x plus 7. So let u equal x plus 7 and substitute accordingly. So wherever we see x plus 7, we'll replace it with a u. So that's u squared minus 10 times u plus 9 equals 0. So you can see the two statements are identical because u represents x plus 7, so some clever factoring there. Now let's go ahead and solve this. So we can factor it. It'll factor to minus 9 and minus 1. So u equals 9, or u equals 1 for that to be a true statement. Now, we don't want to make the mistake of stopping here. We want to solve the original equation, which had x as a variable. So now that we're done with u, we can switch back to x. So when we declare that u is equivalent to 9, that's the same thing as saying x plus 7 is equivalent to 9. If we say u is equivalent to 1, that's equivalent to stating x plus 7 is equivalent to 1. So then we get our two solutions. We get 2 and negative 6. And there we have it. So an equation of quadratic type is an equation that may be quadratic, maybe it's not, but it's definitely structured like a quadratic, and we could usually use some clever factoring to proceed. So let's talk about the last type of equation in this section, which are absolute value equations. So an absolute value measures distance from 0. So you want to keep that in mind. Now remember, distance cannot be negative. Write that down. Right. You cannot have negative distance. That does not make sense. One cannot travel negative 5 miles. You can travel 5 miles in a particular direction, but one cannot travel negative 5 miles. So we want to be careful here. Absolute value will always produce a non-negative value. So an absolute value equation is where you have an absolute value inside an equation. So since absolute value is distance from 0, a lot of times these absolute value equations will come with a pair of solutions, a solution to the left, a solution to the right. So for example, let's look at number 1 to demonstrate the concept. Absolute value of x is 5. So we're saying, hey, what number is 5 units away from 0? Well, we can go 5 units to the left of 0, which is negative 5, or we can go 5 units to the right of 0, which is positive 5. So there's our two solutions. So the x is either negative 5 or 5. Both of those will make equation 1 a true statement. Let's look at something slightly more complex. So here this quantity x plus 1 is 3 units away from 0. So that means this quantity, which we called x plus 1, this quantity is either 3 to the left at negative 3 or 3 to the right at positive 3. Solve each and we get two solutions, negative 4 and 2. Now, it's very important that we isolate first before we split it up. So we'll go ahead and subtract 10 from both sides, which gets us negative 8. Then divide both sides by negative 2 to clear out that multiplication. And we get positive 4. So before we wrap this problem up, notice I did not distribute. That's because the absolute value signs are not parentheses. So do not distribute into absolute values. In order to get rid of that negative 2, we have to divide it away. So don't make the mistake of distributing there. So this quantity, x plus 7, so this quantity of x plus 7 is either 4 units to the left of 0 or 4 units to the right of 0. And that'll give us our solutions. That's negative 11 and negative 3. So make sure you, when solving an absolute value equation, that you isolate first and do not distribute. So one last problem, number 4. We want to go ahead and isolate. We can do that by subtracting 12 from both sides and get absolute value of x plus 5 equals to negative 9. So this expression, x plus 5, is negative 9 units from 0. Well, that's impossible. You can't be negative 9 units away from 0. In other words, can't have negative distance. Absolute value will always produce a positive value. So this is actually no solution. So just be wary there. Remember, absolute value will always produce positive numbers. Alright, and that's a wrap. So we only got one more section to go. The last section is inequalities, and we are almost done with Unit 1. So we're about almost done with a quarter of the class. So keep up the hard work.